Hello, in this video we're continuing our discussion of trigonometric integrals in section 6.2. Specifically, we're talking about the second strategy for evaluating these types of integrals, which is to use a Pythagorean identity along with a substitution. Now in this example, we're evaluating the integral of sine cubed x cosine squared x. So keep in mind that we want to be able to do a substitution at some point. So we have to think about what sort of options we have for a substitution. We only have two functions here. We have a sine and a cosine. So two options for u would be u equaling cosine of x or u equaling sine of x. If u is cosine x, then du is going to be sine x dx. If u is sine x, then du, oops, sorry, I missed a negative there. Du is going to be cosine x dx. So we need what I like to call an extra function. We need either an extra sine x or an extra cosine x. Now remember that the Pythagorean identity with sines and cosines is sine squared x plus cosine squared x equals 1. So we have sine squared and a cosine squared. So what I mean by an extra function in our integrand is if we have something in addition to a squared power, or really in addition to an even power. So in other words, something with an odd power. So the odd power here means that we have an extra sine function. Since we have the extra sine function, that means that du should involve sine, which then in turn means that u should involve a cosine. And then the last thing that means is that everything other than the one extra sine function should be rewritten in terms of cosine. So now to illustrate what I mean, we have the integral of sine cubed x times cosine of x dx. First off, I'm going to pull off my extra sine function. So I'm going to rewrite this as the integral of sine squared x times cosine squared x, sorry, I messed that up, times the sine of x dx. So this we need to keep for du. Since that's going to be du, that means that u is going to be cosine. So we need to rewrite sine squared in terms of cosine. Specifically, sine squared x will be equal to 1 minus cosine squared x. So we're going to have the integral of 1 minus cosine squared x times cosine squared x sine x dx. And before we do a substitution, let's go ahead and distribute the cosine squared so that we end up with a cosine squared x minus cosine to the 4th x sine of x dx. You could have done the distribution later after the substitution. So now that we have done all of that rewriting, we can do our substitution. U is going to be the cosine of x. Du is going to be negative sine x dx. We'll rearrange our negative sign, so we get negative du is equal to sine x dx. So then, rewriting our integral, I'll continue in red, we'll have the integral of u squared minus u to the 4th, and then a negative du, we'll pull the negative sign out, the integral of u squared minus u to the 4th du. We have a couple of very easy antiderivatives to find here. We're going to have a 1/3 u cubed. We'll have a minus, but then I'm going to distribute the negative, so we'll have plus 1/5 u to the 5th plus c, and as with any u substitution, the last step is to substitute back in. U is cosine, so we have negative 1/3 cosine cubed x plus 1/5 cosine 5th to the x plus c. So our final answer then for this example is that the integral of sine cubed x cosine squared x dx is equal to negative 1/3 cosine cubed x plus 1/5 cosine to the 5th x plus c.